Hello and welcome to another of my developing with ArduPilot videos. So I've done a couple of these with Henry, and Henry's away at the moment, so I'm just doing one standalone. And so this series of videos is to try to teach people how to do ArduPilot development. So the particular thing that I'm looking at today is an issue that has been reported with the u-blox M10S GPS. And I've very kindly been sent one of these by QIO Tech. So here's an M10S CAN bus GPS. So this is running an AP-per-if F103 CAN node. And there's an issue where users are getting an error saying that, well, in this particular case, they've got a bad fix, but if I start up, I've got a little system where I can attach the antenna to my roof and it'll get locked, and you'll find that it gets an error where it has a bad configuration and it's failing its configuration. So I'm just working on fixing that bug at the moment. I haven't fixed it yet, but I just wanted to show people how you go about tackling these types of issues, because the methodologies are common to a lot of development tasks in ArduPilot. All right, so when we've got this CAN bus device, now this particular one doesn't have easy access to the debug pins. Now, I could open it up and remove the screws and things and get in there, and I could probably work out how to get a debug adapter attached to it. I might even end up doing that later. But what I'm going to show you is a way of debugging these types of peripherals if you don't have direct debug access. And those separate videos I did with Henry about using a debugger on hardware is for another task. So what I wanted to do is, first of all, attach that CAN GPS to the CITL simulator. And so this, I've got here CITL running. And so I've started it up, and I'll just start it again. So I'm doing sim vehicle, just like you would normally do with a simulator. And just before I ran sim vehicle, what I did was I ran this script, tool scripts can and can CITL node dev.sh, right? So I ran that, and I'll just run it again. It's harmless running it twice. So what that does is that sets up, if I run it here and grow this a little bit, this sets up a virtual CAN device. And I'll just mark myself as closed off there. So virtual CAN device, which we can use to bridge across to the real hardware. All right, so I run this CITL node dev, and this is on Ubuntu 22.04 Linux. It works similarly on all Linux variants. All right, so I've done that, and now I can start up this CITL instance like that, and it will then, and it's rebuilding because I've made some changes to a header, so it'll rebuild and start CITL as per usual. And then what we're going to do is bridge that simulator instance across to the real CAN bus. And so that'll come up in just a second. And then I will show how to do that bridging. Okay, so that will hopefully start up. There it is, as per usual. So it's started up, and now we've got to get the parameters right. And so we, just like on a real board, we've got to set, and it's still fetching the parameters. I don't know quite why it's being quite so slow. I might param FTP that, and there you go, param set CAN P1 driver. There it is. I've got a CAN driver set up. So that's off by default in CITL. You've got to set that to 1 to get CAN. And when you do that, you'll find that these parameters appear and the defaults are fine. I've got CITL on CAN node 10, and I've got CAN D1 protocol to 1. Great. Now, I've also got the default in CITL is that it's got an output to UDP port 14550, which is very useful. Okay, so I can now run this little script. This debug bridge script comes as part of the latest pydronecan. And what you do, now I've got that GPS currently connected via a Zubax Babel, so I have it plugged in here to a Babel like that, but you don't need to use a Babel. You can use any ArduPilot flight controller, which has SLCAN as the adapter to bridge your physical device onto your Linux-based computer. This particular case, I had a Babel sitting here, so I used it, but I could have just as easily used ArduPilot SLCAN on a flight controller. And what this does is this debug bridge takes two valid CAN bus endpoints and it bridges between the two. It just copies backwards and forwards between the two. Right, so I'm bridging between vcan0, which we set up with that little shell script, and in this case, the Babel. I could also bridge it onto a mavcan, right? I could bridge it onto mavcan colon 14550, in which case it would bridge the virtual CAN onto CAN over Mavlink, right? Which would be coming out of this output that we've got here. So there's lots of things you can do, and you can run multiple bridges if you want to, right? And so bridge it onto here. You can even bridge CAN packets from remote sites using the support.ardupilot.org. So you can have somebody on the other side of the planet forwarding the packets to you via support.ardupilot.org, and using DroneCAD Bridge, you can bridge their devices onto your local CITL instance, right? You can even bridge them onto your local physical instances, right? Onto another flight controller. So you could actually make the GPS in Europe appear on your, Pixel 6 or Cube Orange or whatever sitting on your desk, and you would actually get the CAN packets appearing there. So DroneCAN Bridge is a very powerful tool for doing arbitrary bridging of two CAN buses. So I'm just going to start it up here, and it's connecting to vcan0, it's connecting to the Babel, and there it is. Once a second, it reports how many packets it's squirting in either direction, right? And all it does, it's a very simple script. You can read it if you want to in the source code of pydronecan. It's about that long, 30 lines, and it says, start up two threads. Each thread reads a packet on this port. When it gets a packet, write it to the other port. And the other thread does the same, but with the opposite ports. And that's it, right? It's a trivial Python script using pydronecan. Okay, so now we've got it bridged. So we can now fire up our favorite DroneCAN GUI tool. You can also use Mission Planner's GUI tool. And I'm going to connect it to 14550, where it's got this CITL instance, like I showed you before, is outputting to 14550. So here we go. And I'll enable the local node ID. And there we have, there's our ArduPilot CITL instance, node 10. There's our GPS, AP-Perf GPS, the F103 GPS, and there's our GUI tool, all on the bus. And if I plugged in more devices on this bus, another compass and airspeed, whatever, they would all appear. Okay, so that's our basic setup. We now have the ability in CITL to see what's going on. And we can see we're getting this GPS1 failing configuration check. That is the bug that was reported by a user. And so that is the bug we're trying to chase down. So we've reached our first step where we've reproduced the issue. All right, so now we want to go and pop in to have a look at this failing configuration check. And for that, we can pop into the CITL debugger. Okay, so let's go and find where the configuration checks are done. And that is done up in AP GPS. There's this unconfigured, get first unconfigured GPS. So let's go and put a break on that just for completeness, so you can see what's going on. And there it is, first unconfigured GPS. And indeed, there is an unconfigured GPS. So we are getting the problem. All right. Now, when we get this first unconfigured GPS, our GPS driver has something called an error code, right, which tells us why it's unconfigured. So I'll just put a break on that, and we will get that, and I'll delete that breakpoint and move on, and we'll get that error code. Right, it should be. In fact, that error code is AP-perif uses that to spit it onto the bus. We can actually look at it down in here. I'll put on the bus monitor and I'll just record it here and we can have a look at that number. And there's the number there, right? Because what happens, this peripheral, if you go and have a look at tools, AP-perif, and we have a look at CAN, then this is the place where it outputs the GNSS status. And the bit that is missing that is causing this failing configuration check is the fact that this status word from the GPS is not set to 1, right? So jumping around a little bit, if I go to modules, DroneCAN, DSDL, and I have a look at ArduPilot GNSS status, then there's this status word here, which is that, right? So these messages here, or we could go right click and open data type definition, which if you do that, that's a neat little trick in this GUI tool. That gives you exactly this. This is the data definition, and there it is coming straight from the GUI tool. And the bit that it's looking for to not get that error is this status armable. Are we okay to arm? Is this GPS happy? All right, and until that bit gets set to 1, we're no good. And when that bit is not set to 1, then you end up with this error code being filled in. Okay, and here's our error code. Now I'm going to use our favorite little iPrint to convert that into a hexadecimal number. So I on Linux, if you've got iPrint installed, and you end up, that is the error code in hexadecimal, 80008. And we go and have a look at the GPS driver, and you'll find that that error code is just our unconfigured messages. Right, so we now look and see what are, and I know I'm going very fast here. I'm trying to get to sort of broad brush so people know that things are possible, and then I'm expecting that users will then look into the code more deeply. Otherwise, this would be a very long video. Okay, so 80008, well, that is 1 shift left 3, so that's the config rate sol, and 1 shift left 19. 1 shift left 19 is 80000, and config rate sol. So we've got 2 things that are not managing to configure on this GPS. Okay, so now we want to know why that is. And you can already see that before I thought of doing this video, I'm already partway through debugging this, right? I've been adding in, if I show my changes, you can see that I've added in various GCS syntax here for while it's trying to configure these items. And so I've got those already coming out in this little messages popping up in this debug message tab from the CAN node, right? And so now it's a matter of me trying to work out why it's not working. All right. So if we have a look at these debug things, then I put in a little val get message, because the way it works is for configuring the M10, what we do is we do a little val get, which asks the M10, hey, what is your current value for this setting? And we expect to get a reply saying my current value is XYZ. And then we send back a message to it saying, well, we want it to be ABC, please set it to ABC. Okay, so what we do is we do this little send message of this val get, and you can see that we are doing it, right? There's the val get, and that long key number there, if we have a look at the M10 configuration list, that will be this config signal BDSENA. Let's have a, just to confirm that, BDSEN, if I type it right, BDSENA is indeed 1031022, and you can see that key 0 is 1031022. It's really hard to get Discord to stop disturbing you in making a video, so goodbye, Discord. All right, good. So this is the list of config keys we're trying to send off to a the little M10 here, and this message I've just added in here. It just prints out the first key and the count, and we can see we're sending 8, and it is 1, 2, 3, 4, 5, 6, 7, 8. Yes, so that is that. We are trying to send off those val gets, so we're asking it to send them. Okay, so let's now see. We need to see, are we getting the val get reply, right? And what I suspect is we're never getting that reply, and this little M10S is, for some reason, not giving us that val get reply. So what we're going to do is GCS send text mav severity info val get reply, and we're going to length equals %u, right? And unsigned payload length. Okay, this will just confirm, are we getting this reply? Now, as again, having a debugger on this and single stepping it would make it a lot easier, but I'm assuming for the purpose of this video that we can't do that for whatever reason, because I don't have the right screwdriver to open it up or whatever, right? And I may well end up later today opening it up and soldering on cables. I'm a software engineer, so I go to great lengths to avoid picking up a soldering iron because it usually doesn't turn out well. All right, so what I'm going to do now is rebuild that firmware with this extra little debug message in there. And it's because it's reconfigured as CITL, because so board F103 GPS, and then I will rerun that and rebuild that firmware. Great, I've built it. And little note here, I cut down that firmware. If you have a look at APHAL Shibios HWDEF F103 GPS, one of the tricks I did was to disable the compass and other features in here in this GPS, because it makes, I only want the U-Blocks driver. That makes the firmware smaller, which means when I'm cycling through updating this firmware, it's a little bit quicker. So there it is, update firmware, recent. There's my AP perif, newly built firmware. It's going to start flashing that new firmware to this device, and then I'm going to see if I'm going to get a val get reply. And I'm currently betting that I don't get that reply, but let's see. In which case I will be downloading, trying to find the particular reference manual for the M10S and see if maybe it doesn't support the val get message. Okay, so here we are, it's up and running. I'll just clear out the old messages, so we're starting again. And then we're going to see it hopefully starting to do its configuration shortly. Come along, little GPS. There it is, it found an M10. It's sending the M10 settings, it sent a val get. And no reply. Right, so we are not getting a val get reply. So that explains what the issue is, right? This little GPS, for whatever reason, has decided that it either doesn't like our val get request in some way, so it's not going to send a reply, or it doesn't support the val get request, in which case it doesn't have a chance of this working. And so I'll just see if I've got the M10S reference manual handy. And so this is now getting into the weeds of the debugging, and sort of I've done the main thing I wanted to do, but U-Blocks M10S and manual, integration manual, M10S. What I need is down in the, I'll have your cookies. And let's pop down to our documentation. I always find it a bit of a maze in here. Documentation and resources, evaluation, release note, conformity, webinar, integration. It's probably data sheet. M10S datasheet 1.16. No, that's probably not it. I'll bring that down anyway, just in case it's got something useful in it, right? But my guess is that that is not what I want. And max, yeah, I'll just remove those. And so XPDF max M10S datasheet. And does it actually have the protocol? No, this doesn't have a protocol in it. Communication interfaces, UART, I2C approvals. No. Okay, that is not the document we want. So, and it just, val-get. Does it mention val-get at all? No, it doesn't mention val-get. Okay, so we need to go spelunking more. Integration interface manual, perhaps. M10 firmware interface description. And June 21, May, okay, 2.4 megabyte, maybe this is going to be the one. Transfer ublocks, M10 SPG. Let's see if this one is the right manual. Let's search for val-get. Okay, this one mentions val-get. Message used to get configuration value from a list, message configuration layer. What I want to know is which types of devices supported by. Is it perhaps not supported by the S variant of the M10? 64 IDs, U-box. Message returns an ACNAC. We need to start printing out our ACNACs. If any key is unknown to the receiver, invalid layer, can you specify IDs? Multiple times, multiple values, blah, blah, blah. Right. And it doesn't say anything about which ones it supports. Okay. So, I will need to start adding in some debug to print out the ACNACs. All right, so I might leave it there. I'll keep diving into this, but this could be many hours and it'll be an awfully long and boring video if I dive into the deep end on, in this. But I just wanted to give a quick overview video on how you do debugging, how you bridge CAN buses with ArduPilot, and with a very, very powerful feature, and how you update new firmwares and how you integrate real devices into the simulator. So I hope that was useful. And yeah, stay tuned for more ArduPilot development videos in the future.